Thank you, Emma. So we talked about the disc washer method. Now we're going to talk about the shell method. Now, we're going to have two methods for doing the same thing. Taking a region and rotating it about an axis of rotation. Okay? Why do we need two methods? Sometimes it's easier to integrate with respect to x versus with respect to y. And so this gives us some options as far as using a different method. If you have to integrate by hand, sometimes it's easier to use one method versus the other. And so it's just nice to have options. And we will work on this for a couple days. And then on Tuesday, we'll hammer out, okay, this is how you do the disc washer method with this region. This is how you do the shell method with this region. Now, I want you to imagine your quiz. When you drew the rectangles and you rotated them, were they perpendicular to our axis of rotation?
Yeah.
Right? Okay. Well, now we're going to do a method where we're going to rotate rectangles that are parallel to our axis of rotation to create shells. Okay? So, Mr. Griebel really does not like this. But we don't care what Mr. Griebel thinks. To help you remember which is which, I will call them perpendicular. Perpendicular doesn't really.
I like it.
So, but perpendicular has a nice ring to it. Okay, so if you are going to use the disc or washer method, your rectangles are going to be perpendicular to the axis of rotation. Okay. Which means when we use the parashell method, okay, when we use the shell method, we want our rectangles to be parallel to the axis of rotation. Okay, so you see I'm breaking those into vertical lines to rotate around the y-axis, and do you see how they create shells? Kind of like those cups that stack inside of each other. That's what I think of with this. Okay.
Still looks like a washer. So
How does that look like a washer? It looks like a cylinder.
right, but there's still a hole in the middle.
Yeah, so it's a shell of a cylinder.
So what's the difference between that and a washer?
Parashell. I don't think you know the washer is.
Hold on, let me look for a piece of paper. Okay.
Okay. Visuals, it's a lot of work.
Yeah, you're right.
I kind of meant shell, like I was like, I don't know.
Like a shell casing. I guess, okay, how many of you,
What's the difference?
do we have any hunters in here? Okay. What happens, okay, you're a trap shooter, right? Okay, you're a trap shooter. What happens when you shoot? What pops out?
Shotgun shell.
You have a shell, right? Okay.
So the shell is just
Yes.
and hollow.
So when we have,
Think of a soda can without a top or bottom. That would just be a shell.
when we have our rectangle and we rotate it perpendicular, we create these washers, right? Well, if we rotate them parallel, we create shells.
Okay.
Okay, I think this needs. Okay. Now, somebody please help me. How do we, well, this is kind of strange, right? Because it's not really a cylinder because there's that hole in the middle. So let's instead think about taking this green shell and cutting it and laying it flat. What would we have?
It's a rectangle. Yeah, I was right.
We would have a rectangle, right?
Yes.
Okay. So we have this rectangle where we have and it's a three-dimensional, it's like a prism, right? So length times width times height, right? Well, the height we can call the height, but what would be the length of that rectangle?
Circumference.
Yes, the circumference of whatever that shell was.
I'll know.
So that's the circumference of the circle. We have the height. We have the width. Okay. So the volume of each one of these shells would be 2 pi r h times the width. Okay. The volume of the shell. Okay. Now, let's talk about this with actual functions, shall we?
Yes.
Okay. How does this relate to a rectangle that we rotate with a function? So, here's this picture here. Okay? If we take any arbitrary rectangle, the height of those shells would be top function minus bottom function. Right? And what's the distance to the axis of rotation for any given one of these?
Radius.
Yes? That distance would be x. This is x away, x away, x away. Right? Okay. And then its thickness.
So we have a delta x.
Its thickness would be that delta x. The width would be the delta x. So here is your volume. Write it down, circle it, highlight it, star it. Okay? Our radius for right now is going to be x because each of those shells are x away from the y-axis. That'll change Monday when we rotate about different lines.
Is it going to be y?
We'll look at that today. If we're rotating around x, then yes.
We still like talk about this.
Yes. So
Oh, yep.
the height of each one of our shells will be top minus bottom. Okay. So we have top minus bottom times our radius x, 2 pi, and then there's our width of each rectangle. Okay. So if you can remember 2 pi r h, you're good.
Oh,
Now, what's nice about the shell method is you're not having to square anything. So sometimes, if you're having to do an integral by hand, that whole squaring business sometimes creates more work for us. Now, if we have like square root of x squared, that's not a big deal. But when we were talking about, 2 terms or even 3 terms with that squared, that's pretty messy if we have to do it by hand. With a calculator, not so much. Okay? So we are actually going to look at this region right here, and we're going to rotate it about the y-axis using our shell method. So go ahead and write down the equations for me. I know, isn't it so fun to watch?
it's like a state.
Yes. Write down the equations, though, please. do anything, let's go ahead and figure out what our intersection points are. Okay. We're talking about x squared minus 2x plus 1 being equal to 1/2 x. Okay? Or x squared minus 3/2 x plus 1 equaling 0. Oh, you can do it. We have to multiply to 1 without using 1 times 1. Say it. Oh, whoops, this should be 5/2, shouldn't it?
Oh. So, I was getting so close. Nice.
All right, so what we're going to do, we're going to draw. Ooh, didn't pick the right color there. Let's try again. Think green will show up better? Well, I did. I would draw this if I were you, but I already did.
Is that dy?
It would be dx.
Oh,
Because these rectangles are like sitting on the x-axis. Like if we were to move it down. Okay, so this has thickness dx, which means we're going with respect to x. However, we're rotating about the y-axis. So I want you to, kind of like that graphic that I showed you, imagine that rotating around, and I want you to visualize those shells. Okay? So these are parashell rectangles. We're using the shell method. Okay? To use the shell method, we need 2 pi radius times height dx. Okay? Now, each of those rectangles, oops, I don't know if that was good. Each of these rectangles would be x away from the y-axis. So that's our radius. And each of these rectangles would have height, top function, minus bottom function. And our limits of integration are 1/2 to 2. Okay. Let's talk about why the shell. Yes.
So are we always just going to multiply it by this?
I'm gonna say not always, because when we start if we're rotating around like x equals -1, then that's gonna change our radius. But we won't worry about that until Monday. So for today, yes. Okay, but come Monday, no. What? Okay. Now let's talk about this region with the disc washer method. If we were going to use the disc washer method, we would have to do horizontal rectangles. But notice how my right function changes, or excuse me, my left function changes over here. So being able to use dx's is helpful because we only have to make one integral, and it's nicely set up. Okay, so there's going to be times where we want to do dx and we want to do dy, and so being able to flip back and forth between the methods is going to help us. Okay?
Would you even be able to do dy because it like run into the same function like at the bottom of x
Well,
minus 1 squared?
if we did dy, we would have to solve for x here. So you would have x minus 1 equals plus or minus square root of y. So y equals 1 plus or minus square root of y. So like this is 1 plus square root of y, and this is 1 minus square root of y. And you'd have, it's a mess, right?
Yeah.
It's a mess. So being able to keep it in terms of x and use the shell method helps us a lot. Okay? All right. You ready for another one? Write down the equations and draw the region.
So basically, you just draw
Only to pi though. That was close. Whew. Looks like that. Right? From 0 to pi.
What I drew was
0 to 2 pi would be
0.
this. 0. What?
The area.
Okay. So imagine rotating this around. What is it going to look like?
Like a flower.
Like a butt cake. Okay? So I'm really sad. Juniors, we might get to do this when the seniors leave, but since we've had so many snow days, we don't have time to do it. But in the past, I have made a butt cake and brought it in, and we've actually measured and created equations for the bundt cake and done a volume of revolution to figure out the volume of the cake, and then we eat it. But we don't have time to do that because of your very wanted snow days.
I don't want
Day.
You don't want them anymore?
No, I'm sick of them.
Yeah, I'm kind of tired of it. See, it was all fun and games, and then my dad started making me shovel my thing. Nah, it's not.
But you shoveled the most snow Omaha's had in February. Okay,
Tragic.
so here's the deal with this problem. We can't write this in terms of y. Our only option is to keep it as y equals the sine of x. So our only method of choice here is the shell method. Okay? So our shell method is 2 pi integral of radius times height, thickness dx. Okay? All of our rectangles are x away from the y-axis. And what's the height of all those rectangles? Sine of x.
That's easy.
Yes, sir.
Where's that not gonna equal x?
When we rotate around a line that is not the y-axis. Okay. So go ahead and punch this into your calculator. I would punch in the first part, multiply it by 2, and then we can add the pi in after.
Okay.
Oh, yes, yes. Good question, Autumn. Your mode better be in radian since you're putting in a trig function.
My calculator.
Lit. I got pi.
It's Okay, so you got pi for this right here.
Yeah.
So 2 pi squared. That's kind of fun, right? Okay. What do you think so far?
Not too shabby.
I like the shell method better if I were to have to choose between the two, but yeah. Okay, so we're gonna do one more example. Draw the region. Do I need to close my blinds? Are we okay? I wanted to see the sunshine. Our region should look like this, correct? Okay. Aaron, what would this intersection coordinate be? When is x squared equal to 4x?
Oh. But X is 4.
Okay.
Oh boy.
So y would be 16. Okay, so I want to rotate around the x-axis, but using the shell method. Okay, if we are going to create shells, we need parallel rectangles here,
Oh, so it's the opposite.
and parallel rectangles would mean we have thickness dy. Okay. We are going to set up our integral the same, except instead of top minus bottom, we'll use right minus left and translate things that way. So first of all, let's talk about, we have 2 pi integral of radius times height times width. Okay. Since we are in terms of y, we're going to use 0 to 16 as our limits of integration, because those are the y values for our intersection points. Okay. Now, everything else is going to stay the same, except we're just in y's instead of x's. So, the distance from any one of those rectangles back to the x-axis is y. So our radius is y. And then the length of those rectangles are going to be right minus left. So our right function is the parabola, minus our left function is the line.
Oh my.
Did you forget to change them to?
Yes.
Okay. So we had to change these to y, but was it that hard to change these to y? Okay. And to be very honest, this would be a pretty nice one to do by hand, because you would have 2 pi, but then this would be y to the 3 halves minus y squared over 4, and that wouldn't be terrible, right? I mean, yeah. We can take those antiderivatives very easily. Do we get an irrational?
428.93.
Okay, did you multiply by 2 pi?
Yeah.
Okay, so what did you say?
428.93.
One more decimal place for me.
932.
Thank you.
Nice.
Okay, so on your gold sheet, you have some problems, just like we've been doing in the past, where some of them I'll let you do with a calculator, Math 9. Some of them I require you to do by hand. Wednesday's quiz will be calculator, non-calculator. Friday's test will be calculator, non-calculator.
You're still having that AP day, man.
Yeah, what if like this day would be just
So instead of the AP day, I'll give you an AP problem to take home as homework that day.
So we don't have it.
You'll have the work, but not the day. Okay? We have about 13 minutes left in class. I want you to get a picture or a book, the book or a picture of the book somehow, and try 2 problems before you leave. Okay?
I got
Can I take a picture of your
Yeah, that's fine.
Someone airdrop it to me?